Welcome, students. This is Mr. Campbell here, back again with a short lesson actually today that is being used for kind of the first 15 minutes of class before doing our notebook quiz in our in-person class. But as you guys know, for our online classes, we already have had some of our notebook quizzes in the form of notebook checks and this and that. So that our newest notebook check should be posted soon later this week. But as you can see here, all we have for today are just two video questions on a very controversial topic. Number one, how do we know the Earth is not flat? Again, you're going to write this down on page 10. And then number two, what would be different if the Earth was flat? Again, just some updates for my online students. We have our writing assignment needs to be turned in and completed. We also have, as of today, as of recording this, I have just posted, recording this, I have just posted the lab assignment, which is just all about the moon phases. So if you are confused on that, again, please watch the moon phases lab video, which I did because we cannot actually do the lab in person, right? And you'll see that has to do with kind of some lamps and things like that. You'll see that in a while. So yeah, so you should have already watched that prior to watching this. So let's go ahead real quick. Just find out again, how do we know the Earth is not flat? And two, if the Earth was actually flat, how would the planet be different, right? What would be different about our planet? What would change there, right? Than as it is now round, right? Let's go ahead and double check. I got actually a quick question before I show the videos. So let's do some quick practice questions here. Give me one moment to set up our first practice question of the day. Actually, I think it's in this. Hold on, guys. Just trying to find. All right, let's go ahead and. Give me one moment. Looks like YouTube is. Looks like YouTube is starting up, and that's not what I want.
Let me show you how I create engaging.
Okay. All right, let's go ahead and take a look at our first question today. In what direction does light/shade move on the moon? And light shade on the moon move? Is it A, upwards, B, downwards, C, to the right, or D, to the left? Pause video, see what you think. Answer is going to be to the left. Always going to move from right to left, right to left. Let's go ahead and check out now our first video of the day. How do we know that the Earth is not? Top 10 reasons why the Earth. Hold on. Top 10 reasons why we know the Earth is round. Why we know the Earth is round. Let's check it out. Let's check it out. Oh, gotta put my audio in. All right, hopefully the audio sounds okay. All right, let's check it out.
Number 10. All the other planets and stars we've ever seen are round, and there's no reason to indicate that the Earth should be any different. Number 9. Time zones. Day and night happen at different times at different places on Earth. In fact, it's always day somewhere and night somewhere else. Number 8. The Coriolis effect means freely moving things like cannonballs or hurricane winds are deflected to the right, but only if you're north of the equator. If you're south of the equator, they're deflected left. Number 7. Triangles. If you walk 10,000 kilometers straight along the Earth's surface, turn 90 degrees to your right, walk 10,000 kilometers more, turn right again, and walk another 10,000 kilometers, you'll be back to where you started, having successfully made a triangle with 3 90-degree angles. As any geometry student can tell you, this is impossible on a flat surface. Number 6. The sun, in general, gets lower and lower in the sky as you travel away from the equator, and you can use this to directly measure the Earth's curvature. Pick 2 places a few hundred miles directly north and south of each other, and at noon, measure the shadows cast by a vertical meter stick at each location. You can use the shadow lengths to figure out the angle between the sticks, and once you add in how far apart they are, you can calculate the Earth's curvature. Number 5. The stars at night change as you go north or south. For example, Orion is upside down if you're in Australia. Number 4. Ferdinand Magellan, and many people afterwards, circumnavigated the Earth. That means he left headed west, continued going west, and came back to where he started, still going west. Actually, Magellan was dead, but one of his ships, led by Juan Sebastian Elcano, finished the journey. If you head west and circumnavigate the Earth yourself, you'll be able to tell because you'll observe one fewer sunrise than everyone who stays at home. Number 3. The horizon. Ships on the ocean or tall Chicago buildings viewed over Lake Michigan disappear bottom first, and you can see the sunset twice if you watch it lying down and then quickly stand up. The simple fact is, if the Earth were flat, there wouldn't be a horizon beyond which things could disappear, so from across Lake Michigan you'd be able to see all of Chicago, as well as the Rocky Mountains. Number 2. During a lunar eclipse, the shadow of the Earth on the moon is curved. And number 1. We know the Earth is round because we have photographic evidence.
All right. So again, an abundance of evidence that the Earth is round and not flat, right? Some of the main ones, again, you should have written these down on page 10, guys, page 10 of your notebooks, include the horizons, right? We're able to see the Earth curve. If you go out in the ocean, you can't see the other lands. You can't see farther than the ocean because the ocean, again, curves down and the planet is the shape of a sphere, right? Secondly, planets and moons, everything else in space is round. So why wouldn't ours be, right? Third, time zones. If the planet, different parts of the planet experience different times of day. If the planet was flat, it would be near impossible to explain this. And then lastly, stars and satellites. Again, they change positions. Satellites can take photographic evidence of the planet being round, right? Other than artist renditions, you'll never see or find a picture of the bottom of the planet as a flat planet, right? You just won't. Okay, number 2, what would be different if the Earth was flat? Again, I am limited on time, so we won't watch all of this, but if the Earth was flat, well, what would our planet feel like and what would it be like, right? Let's check that out. I'm only going to play 6 minutes of this because of time, guys. So again, if you want to watch all of this video, look, what if the Earth was flat from the What If YouTube channel. A lot of cool videos, a lot of good scientific stuff they show us.
Revolve around the sun, or would the sun rotate around it? And why would you never walk to the Earth's edge? This is What If, and here's what would happen if the Earth was flat. In case you missed the news on the Flat Earth channel, here's a quick recap. For thousands of years, the general public thought that the Earth was flat and everything revolved around it. Then, Nicolaus Copernicus came around with his spanking new theory. The theory said that the Earth wasn't flat and definitely not the center of anything. His observations led him to believe that our planet is orbiting the sun. But here we are, 500 years later, and some people around the globe are convinced that the Earth is flat. Well, how would this even work? Do you know why the planets form in a spherical shape? One word: gravity. Gravity is what's pulling matter together equally from every side. And as a result, matter forms into a sphere. Of course, this wouldn't be the case for a flat Earth. Anti-round earthers think that there's no such thing as gravity. We only feel like there is because some mysterious force is accelerating the pancake-shaped Earth upwards. I don't need to tell you that you can't increase the speed forever. At some point, you'd be going too fast. Ugh, does anybody feel like a burnt pancake? No? If you want some real science, then yes, there would be gravity on a flat Earth. And it would be weird. The center of gravity on a flat Earth would be right here in the middle. Everything on Earth and around would be pulled to this point. And the further you got away from the center, the stronger this pull would be. At some point, it would begin to pull you downward, so you would have to start climbing. This would be the reason why you couldn't walk to the edge of a flat Earth. gravity would be so strong around there that it would be impossible for you to make it. You might never see the gorgeous 45-meter tall wall of ice called Antarctica, guardrailing the Earth's edge. And you'd never learn what's on the flip side. But at least you wouldn't fall off of it. There would be other side effects of this funny gravity. Objects closer to the edge of the Earth would fall sideways instead of down. Gravity would also make trees grow diagonally on most of the pancake-like Earth, because they'd be reaching against the pull of gravity. All the rain, snow, and hail would fall toward the Arctic at the center of the Earth. The precipitation would converge and start to build up. The oceans would get sucked to the center of the disk too, and form one big ocean in the middle. A big concern would be the air pressure on a flat Earth. Gravity would draw too much air toward the Earth's center, leaving the areas around the edge with no air pressure at all. That would be bad because people living in a flat Earth Australia wouldn't have enough oxygen to breathe. And if you lived closer to the middle, where the Arctic would be, you'd be crushed by the weight of the atmosphere. But not for long. A flat Earth wouldn't have a geomagnetic field around it. This field is generated by the movements of the Earth's core, and, well, a flat Earth just wouldn't have one. Nothing would be holding our atmosphere in place, and eventually, it would spill into space. We'd be exposed to solar radiation that would cause cancer and damage our DNA. And we'd have no breathable air anywhere on the planet. So, I hope you're able to find a life support system lying around. Now, let's get to those questions we've all been waiting for. What would orbit what in this arrangement? Would there be a day and night cycle? Or time zones?
All right. So
Every flat earther.
you can watch the rest of that on your own. We are limited on time for this recorded lesson. Some big important things that really discredit the flat Earth theory here is that if Earth's the shape of like a disc, if it's flat, it really would not be a good situation to have that magnetic field, which would then make the atmosphere very unstable. Okay, so in a stable atmosphere, we also get gravity that's like sideways. So trees kind of bending sideways, weather falling sideways towards the center. And gravity would be pulling you sideways instead of down towards the core of the Earth, right? And then lastly, our daily cycles and seasons would be a lot less organized and kind of, because the Earth has to tilt to make winter and summer, right? But if it's flat, it doesn't tilt really. So then you wouldn't have those distinct seasons that we know of. Okay. So keep that in mind for page 10, guys. That concludes our lesson for today. Again, a short lesson because the students that are in person are going to be taking their notebook quizzes. My online students, you guys are taking the notebook checks for those instead, and the online test as well. So this is Mr. Campbell. If you guys have any questions, let me know. This is Mr. Campbell signing out.